Alright, so in this video I just want to talk about a couple of application problems, or maybe just one application problem for compositions. Um, so the first problem, or the problem that I want to look at in the video, is from Calculus for Business, Economics, and the Social Sciences by Hoffman and several other authors. It's the 11th edition, and the problem goes something like this. Arthur, the manager of a furniture factory, finds that the cost of producing Q bookcases, so this is a Q, during the morning production run is C of Q is equal to Q squared plus Q plus $500. Okay, so we have a cost function based on a quantity. On a typical workday, Q of T, that is the quantity as a function of time, equals 25T bookcases. And they are produced during the first T hours of a production run for 0 less than or equal to T is less than or equal to 5. We have a little statement about the domain of this Q of T function. So part A says express the production cost in terms of T. So I want to have, right now I have cost in terms of quantity, right? I have these two functions. And the reality is I want to figure out what the cost is with relation to time. So this is a composition of functions, right? Q of T gives me an output that's quantity, and I can put that output into this cost function to figure out the overall function. So I will find C of Q of T and put this 25T in everywhere there's a Q in C. So let's do that. So I have 25T squared plus 25T plus 500. Okay. When I square 25T, this square is on the 25 and the T. So 25 times 25 is 625. Distribute that squared. 25T plus 500. So this is the cost as a function of time now. Okay? Okay, so now let's go to the next question. How much will have been spent on production by the end of the third hour? So what's the cost at the end of the third hour? I'm going to rewrite this cost function that we just found. $625T squared plus 25T plus 500. And I am trying to find cost of 3 when T equals 3, the third hour. So I'll plug in 3. It's a time measurement, so I know that it goes into the time variable. Okay? And then let me plug that into my calculator, and you guys do the same, please. Check me. And I get that the cost is $6,200. Okay? Now, what's the third question? What's the average cost of production during the first 3 hours? And remember, I think we talked about a problem with average cost is equal to the cost function, C of whatever, divided by the quantity. So it's cost per unit. I'm trying to get an average cost per each unit. Okay? So in this case, my average cost should be C of T divided by Q of T, because I have both of those in terms of T. And maybe you're thinking of this as C of Q of T, this composition function, like this. Okay? either way, I want to do it for the first 3 hours. So I'm really thinking of C of 3 divided by Q of 3. Okay, so from the previous problem, I know this one, right? I found the cost at the end of the 3rd hour to be $6,200. I want to find Q of 3. Let's do that. Q of T is equal to, what was it equal to again? 25T. 25 times 3 is equal to 75. Looks like I can make 75 bookcases in the first 3 hours. So I'll plug those two numbers in. 6,200 divided by 75. And I get an average cost of $82, and it looks like 67 cents per bookcase. Okay? If the cost to produce the bookcases is evenly divided. Okay? Let's do, I think there's one more question in this problem. This should be budget, there's a typo there, allows no more than $11,000 for production during the morning production run. When will this limit be reached? Okay, so I have one quantity here, $11,000, and I have to figure out where that number goes in all of the formulas that I have so far, right? So I have a cost function, C of Q of T. Let me write that down again. That's 625 T squared plus 25T plus 500. I also have a quantity function, 25T, I think it is, right? And so I'm trying to figure out, where does this $11,000 go? Q is a quantity of bookcases, that's in units. T is in time, that should be in hours. And cost is my only one that's in money, right? So I should plug in this $11,000 right here into this side for the cost and figure out when that is, right? When will this limit be reached? When is a question that's answered by an answer in T, in number of hours, right? That's a time measurement. When is a time question? Okay, so I'm going to go ahead and plug in 11,000 here, and then I get this quadratic formula, okay, or this quadratic equation. So I want to go ahead and solve here for 0. I'll subtract 11,000 from both sides, so I think I get minus 10,500 on this side. And then you can, 25 is definitely factorable. You can factor it out of here if you want. When I do that, let me divide 10,500 divided by 25 to figure out this should be minus 420, this last one. So you can do that. That doesn't look like it helps me. I definitely don't want to, gosh, I would hate to try and factor that thing. I'm just going to go ahead and use the quadratic formula since I know what it is. I know that it's going to work. And it looks like factoring is going to be a pain. So let me go ahead and do that. So I have T is equal to, and this is the negative B plus or minus the square root B squared minus 4AC over 2A. So T is equal to negative, and here, since I factored this out, I'm going to go ahead and use these smaller numbers. Here's my A is 25, B is positive 1, and C is negative 420. So I'm going to use those numbers in here. So negative 1 plus or minus the square root 1 squared minus 4 times 25 times negative 420 over 2 times 25. Now you can do these in different parts if you want to. I'm going to go ahead and plug this whole thing into my calculator to avoid rounding. So I'll use parentheses. And when I plug in, let's see, I'm going to do the plus one. negative 1 plus this is the one that I'm doing. And there's a 50 down here. If I do this, and I just want to make this note, if I use this minus version, negative 1 minus this square root of whatever, I'll get a negative number, right? And you can try that on your calculator. You get a negative number, which isn't really a good output in terms of time. We don't, aside from Back to the Future, we don't really talk about negative values of time. So we want to go ahead and just use the positive value. Guess somehow I thought the Back to the Future joke was actually funny when it's really not, but you know. Okay, so I want to go ahead and put these numbers in. And when I do that, I get t is equal to 4 point, I think I get a 0.8 when I round it, hours. So right around 4 hours, I hit this $11,000. A little bit over 4 hours, I hit the $11,000 mark for costs. Okay? Okay. So that's that problem. Let me see. Let's take a look at this next problem and maybe a couple questions. This is from a different calculus book, Essential Calculus by Wright, Hurd, and New, and published in 2008. And the problem looks like this. Two students create a computer program which connects dots on a grid so that two players can play Chase the Rabbit. They buy blank CD discs at a local store for 50 cents and sell them for $5. They pay another student $27 per day, 5 days a week, to answer the phone, take orders, relay customer questions, and make duplicates of the master disk. So it tells you, let X denote the number of disks made. Let C of X be the weekly cost function, the total cost, and let R of X be the revenue function. So the first question says, write an expression for cost for C of X. So we've gone through an application problem. I encourage you guys, if you printed this problem out, to go ahead and try it again on your own. Write this cost function. Part B is write the revenue function. Go through and then come back and compare and see what you get. Okay, so I want to write the expression for C of X. I'm telling you, you should push pause now. Spoiler alert, I'm about to go through the problem, right? Okay. Write the expression for C of X. What is the weekly cost of producing 500 discs for C? So cost. So I have two parts to the cost, I think, when I read through this problem, and sometimes you might have to read through it twice. But they're buying discs for 50 cents each, and they also have a payout to this other student of $27 per day. So the cost is the cost of discs plus the student, right? That's what they're spending money on. So the disc costs 50 cents each, is how I interpret that. So I got 0.50. And let's say the number of discs is X. I think that's what we said. Let X denote the number of discs made. Plus what it costs to pay the student. $27 a day times 5 days a week. Oops, I put a 5 in there. 27 times 5 days a week. Okay, so the cost should be 0.5x plus, and I think this is 135. Okay. Okay. Now, the second part of the question says, what is the weekly cost of producing 500 discs? So, and this is what I would call a C of X function, right? Cost as a function of X. So C of 500, how much does it cost to produce 500 discs? 0.5 times 500 plus 135. So let me put that into my calculator. And I get $385. Okay, is that what you guys got? Okay. Good. And that seems maybe reasonable to me. You're making 500 discs. They each cost you 50 cents. So that should be around $2.50 plus his other payout. Part B, write the revenue function. Okay, revenue, how much money they're bringing in, right? Okay, so here in this revenue function, I think, are bringing in money from one place. And look back in your problem, I believe they're selling the discs for $5 each. Okay, so I think my revenue function, again, X is the number of discs, is $5 times however many they sell. Okay? So I think that's kind of a really simple, but I don't think they're making money in any other way. Now, how much revenue is produced by the sale of 500 discs? Our 500 equals 5 times 500. I think I get $2,500. They make $2,500 by selling 500 discs. Okay? Let's do part C. Write a profit function. Profit is how much you bring in, revenue, minus how much you had to put out, cost, right? So in this case, R of X minus C of X. Our R of X is 5X, and our cost function is 0.5X plus 135. So let's simplify this. 5X minus 0.5X minus 135. I get, that's 4.5X minus 135, I think, for profit based on the number of discs. Okay? And determine the profit from the sale of 500 discs. Profit from 500 discs equals the revenue of 500, which I've already found, minus the cost of 500. Or you could put 500 into the profit function. But I've already plugged these numbers in and I know what they are. So let me go ahead and put that in here. My revenue was $2,500 and my cost was $385. So let me, on the calculator, I get $2,115 per week, right? This is a weekly profit. That's pretty good. Okay. And I think that's the weekly profit based on the sales of 500 discs. Okay. D. How many discs must be sold in order to break even? This idea of breaking even is kind of what it sounds. It's the point where you're putting out as much money as you're bringing in. So where R of X is equal to C of X, this is called your break-even point. Okay, so I'm just going to do that. Plug in my functions. Where's my function R of X? R of X was 5X. And the cost function was 0.5X plus 135. And I'll just solve for however many discs I need to sell. So I subtract 0.5 from both sides. And then divide by 4.5, 135. And I get X is equal to, oops, not money, right? X is a quantity, is 30 discs. Okay, the last one, which I would like you guys to think about. A business professor estimates that the campus craze, I have a lot of typos here, craze, for the game could become national, and therefore the game could be marketed nationally. If 100 colleges were to become market sites, how might the cost and revenue functions be affected? Based on your thoughts, write new functions for cost, revenue, and profit for the 100 colleges combined together. So I'm not going to do this. Will you guys think about this and talk about it with your fellow classmates, how you think that this would be affected? Okay, so, but that's the end of functions and applications of compositions. So let me know if you have questions.